recurring decimals. What are those? These are decimals with numbers being repeated. For example, number 1, 0.2. The 2 is having a dot on top. What does that mean? That is telling you that the 2 is repeating continuously. So you are having the number 0.2 recurring. It's the same as 0.2222222222222, as many as you could write. And then 0.45 recurring. And then in this case, please take note, both the 4 and the 5 are recurring. They have a line on their top. So that is the same number as 0.45, 45, 45, 45, 45, 45, as many as you could write continuously. And then same applies to the last one, which is 0.245, 245, 245, 245, 245, 245, 245, continuously. Now we are required to convert these numbers to fractions. What's the idea behind this one? What do we use? We use the sum to infinity. So let's see. So for sum to infinity, we need to get the ratio r. So first things first, 0.22222 can be written as 0.2 plus 0.02 plus 0.002 plus 0.0002 continuously like that. So from there, let's find our r. So our r is going to be equals to, don't commit this foul, we don't write 2 equals 4 a second line. So our r is going to be this over this, or if you like, this over that, if you like, this over this one. So it's the term 2 over term 1, term 3 over term 2, term 4 over term 3, just like that. Now let's work this one out. So this is 0.02 over 0.2, and this is giving me 0.1. So the sum to infinity in this case, sum to infinity is equals to a, which is the first term, over 1 minus r. And then in our case, the first term is 0.2 divided by 1 minus 0.2. And this is giving me 0.2 over 0.8. And then if you multiply both the numerator and the denominator by 10, you are going to get a 2 over 8, which is the same thing as a 1 over 4. And we have successfully converted that number to, let's fix an error here. There is an error. For our r, we got 0.1, but when substituting r, we substituted 0.2, which is wrong. Let's fix that 0.1. Then this is giving us 0.9. and then multiplying by the 10, you are going to get your 2 over 9, which will be your answer. Let's check this from a calculator. 2 over 9 is actually 0.2 recurring. Next question. Next question, we are required to write 0.45 recurring as a proper fraction. Let's go ahead and do the magic. So for this one, 0.45 can be written as 0.45 plus 0.00, replacing the taken out 4545 plus 0.4045 plus 0.60 plus the others there. Now from there, let's calculate R. The common ratio is going to be 0.0045 divided by 0.45. Our calculator is here. Fortunately, 0.0045 divided by 0.45. It's giving me 0.01. Now let's go to the sum to infinity. So the sum to infinity is going to be equals to, so the sum to infinity is going to be equals to A first term 0.45 over 1 minus R 0.01. So this is going to be equals to 0.45 over 0.45 over 0.99, 0.99. Then if you multiply both the numerator and the denominator by 100 over 100, you are going to get 45 over 99. Let's confirm if that actually gives us the 0.45 recurring. So it's 45 over 99. That's what it's giving us, 0.45, 45, 45, 45, 45, and then the last one that's rounded up. Next question, 0.25, for all three numbers are recurring in this case. So let's write it in an equation form. It's going to be in a series form. It's 0.245 plus, then the 245 are gone, so let's replace them with 3 zeros. 245. Now the 245s are gone, replace them with 6 zeros, and then just like that, then let's calculate. R is equals to 0.123245 over 0.245. Now let's use our calculator for that. 0.123245 over 0.245. That's giving me 0.001. Now let's go to the sum to infinity. Sum to infinity. Sum to infinity. This is equals to A 0.245 over 1 minus 0.001. Then this is going to give you 0.245 over 0.999. then multiply both the numerator and the denominator by 1000. You're going to get a 245 over 999. Let's confirm. 245 over 123. And that's it. Hopefully this lesson was more educational. Stay tuned for more.